Asteroid Dimorphos, which collided with NASA's spacecraft, is acting strangely. Astronomers have observed an unusual behavior in an asteroid that collided with a NASA spacecraft recently. The incident caught the attention of high school students who made the discovery while studying NASA's DART mission in the Didymos system. According to a study published in the science magazine, The New Scientist, the asteroid Dimorphos is exhibiting unexpected behavior following its collision with a NASA rocket last year. As mentioned in New Scientist, NASA's primary objective was to reduce the orbit of the space rock around its parent asteroid. While the mission achieved success, Dimorphos' orbit has continued to diminish. The study reveals that a space rock approximately 580 feet wide, 177 meters, was intentionally crashed into by NASA's spacecraft called DART, short for the Double Asteroid Redirection Test. After this collision, Dimorphos began to change its orbit in a peculiar way, leading astronomers to describe its behavior as weird. The New Scientist reports that Dimorphos, the asteroid that was impacted, is now rotating in an unusual manner while still following its usual orbital path. Initially, NASA believed that their DART mission had no significant impact on Dimorphos. However, this changed when the findings of a high school teacher named Jonathan Swift and his students contradicted NASA's predictions. Swift, a high school teacher in California, and his students were the first to detect deviations in Dimorphos's orbit after the collision. They used their 2.3-foot-long telescope to study the asteroid. Several weeks after the impact, Dimorphos's orbital speed slowed down by 33 minutes. Swift and his students determined that the asteroid had indeed been slowing down since the collision, and this slowdown was occurring at a rate of 1 minute per period. However, what surprised Swift and his team even more was that their calculations didn't perfectly match NASA's observations. Instead of a 33-minute slowdown, they observed a change of 34 minutes. Jonathan Swift told New Scientist, "The number we got was slightly larger, a change of 34 minutes. That was inconsistent at an uncomfortable level." Swift presented his findings to the American Astronomical Society in June. In response, NASA's DART team confirmed that Dimorphos had indeed continued to slow down after the impact. However, their calculations indicated an additional slowdown of only 15 seconds, not a full minute. The rate of slowdown had stabilized after the collision. To understand what was happening, Dimorphos slowed down because of the collision. During the collision, some of its parts broke apart and scattered along its regular path. Whenever Dimorphos encountered these rocky fragments, it experienced a slowdown. After about a month, when it had passed all these obstacles and cleared its path, it resumed moving smoothly without changing its speed, reaching a state of equilibrium. While the DART team has yet to release its official report on these findings, we may gain more insight into this phenomenon in 2026 when the European Space Agency spacecraft, Hera, is scheduled to arrive at Dimorphos for a comprehensive investigation. DART is the first-ever planetary defense test. It's designed to alter the motion of an asteroid, demonstrating our ability to mitigate potential threats to Earth caused by asteroid impacts. By crashing a spacecraft into an asteroid, the moonlet of the binary asteroid system Didymos, DART provides valuable data on the dynamics of asteroid deflection, aiding our understanding of celestial objects. If successful, DART sets a precedent for global cooperation in planetary defense. It's a proactive step in ensuring the safety of our planet from potential asteroid impacts.